Hi guys, welcome to the National University of Malaysia, university that inspiring futures, nurturing possibilities. Today, I will bring you guys around UKM. Let's go!
Now, so we have like half an hour, so I will start with your next chapter before we have to rush a little bit on Thursday, okay, sebab nak habiskan ada chapter. Sekejap, saya cakap hari tu awak punya quiz bila malam ni
Oh, doktor, quiz malam ni.
Apa?
Tu doktor tak confirmkan lagi.
Quiz 9.30 boleh kan? Quiz 15 minit je.
Boleh doktor.
Okay, 9.30 Saya pun tak nak kat ni lagi. Tak prepare soalan lagi. Soalan ni nanti mantau saya, sekejap lagi saya fikir-fikir soalan-soalan menarik. Alright. Okay, so by the way, I think last time previous class saya dah settlekan semua sampai sampai axis symmetry. Okay, so nanti saya bagi assignment lah untuk chapter tu, shallow foundation tu. Okay, ada any questions ke for shallow foundations? No, yes, no, yes, no, no, no. Tak ada Okay. Okay, alright. So we continue with the next chapter, which is vertical stress increase in soil. Okay, so you understand that when you have a loading on soil, so you are applying stresses to the ground. Okay. So the reason why we have to look into vertical stress is, okay, it depends on the loading that we impose on our ground. Okay, so it can be point loading, distributed loading. Okay, it can be one dot, it can be bigger. Okay, so it all depends, right? So the allowable settlement of a shallow foundation may control the allowable bearing capacity. Okay, so the fact that your soil, okay, can allow settlement for a shallow foundation, it is actually being controlled by the soil bearing capacity. Okay, so understand the word itself, bearing. Okay, dia menahan. I have to bear this. Okay, so the soil have to bear this. Okay, so how much is the capacity? So let's say 100 kilonewton per meter ke, okay, 1000 ke, berapa, 500 ke. So that is how much the soil can sustain, can bear the loading. Okay, so the allowable settlement may be controlled by local building codes. Okay, so you understand in your standards. Okay, so when you design, okay, so you look, okay, whether it's going to be a school, a residential, a house, a 2-story, 3-story, an office or whatever. So those codes, okay, they provide you with the specific loading, how much for the ground have to bear, okay, depending on type of building. Okay, the allowable bearing will be smaller for the following conditions. Okay, so Q all, okay, say Q allowable, okay, equals to QU over FS. Okay, so last week we have learned, okay, so to calculate FS, okay, is QU over Q all, okay, or Q all is actually Q allowable minus Q settlement. Okay, all right, so we are going to look into, okay, further up. Okay, so the calculation of foundation settlement requires estimating the vertical stress increase. Okay, you are looking at vertical stress increase in the soil mass due to net load applied on the foundation. We will discuss the general principle of estimating the increase of vertical stress at various depths in soil due to applications of. Okay, so you can find, okay, how much the loading is imposed on the soil into the ground at different depth. Okay, so maybe you want to know at 1 meter how much the loading of the soil and the surcharge is. Maybe you want to go deeper, maybe 5 meters, 1 meter, then 5 meters, 10 meters. So at all different depths, you will have different surcharge and loading imposed on. Okay, so what kind of surcharges? Okay, so you have a point load. Okay, ibarat you ambil pen, you letak jari awak, okay, and you just pinch and you just point it onto the ground. Okay, so the loading is coming via a point load. Circularly loaded area, maybe in circular area. Okay, vertical line loading. Okay, so vertical line. Okay, straight load. Okay, horizontally. Okay, rectangularly loaded area. Okay, in rectangular shapes. Embankment type of loading. Okay, embankment macam pyramid macam tu lah. Okay, so imagine embankment, usually where do you have embankment? Dekat tepi jalan, dekat railway, train track. Okay, before you make a train track, usually you have the embankment. Okay, ditambahkan. Is it tambahkan embankment? Bahasa Melayu dia saya tak ingat. Alrighty. Boussinesq 1885 developed the mathematical relationship for determining shear stress at any point on surface. Okay, so imagine at any point on the surface, so Boussinesq they look at the mathematical relationship. Okay, so berapa loading sini kena, berapa loading sana kena, berapa semua. Okay, referring to the figure on the following slide, we determine the vertical stress increase at point A caused by a load of magnitude P by the equation. Okay, saya pakai buku lah part ni sebabnya slide ni tak besar. Okay, so vertical stress increase. Okay, alright. So when we look at what Boussinesq has mentioned, okay, so changes of stress equals to 3p over 2 pi z square 1 plus r over z 2 5 over 2. Okay, so p is the load of magnitude. Okay, the vertical stress increase at point A means, okay, you see this point A. Okay, so imagine this is your area. Okay, okay, this is your ground. Okay, so this is going to the x-axis, this is going to the y-axis, but this square is actually like this. Okay, they're horizontal. Okay, and then where it's like that lah. Okay, and then you have your z-axis. Okay, this z-axis is going down. Okay, so imagine if A ni adalah dekat X, okay, jarak dia banyak ni, dekat Y jarak dia banyak ni, and then it goes down. Okay, so that's why you have the value for X, Y, Z. Okay, right. So at point A, okay, so how much does the stress, the vertical stress increase is? Okay. Alright, so like I said just now, okay, so vertical stress, okay, this one is vertical stress. Okay, so ini dah dia, vertical stress, okay. The change is triangle, and then this sigma is stress, okay. So 3p, okay, over 2 pi z, okay, pi, okay, z. Z is this height, okay, and then 1 plus r over z, okay, so we take it as radius, okay, so r equals to x square plus y square root. So this is your theorem Pythagoras. There's no problem, I'm pretty sure you can do that. Okay, so that is all. Okay, so p is the load magnitude, so p, this is p, okay, so, but you have 2 times with 3, okay, that is the equation. All right. So, know that equation 8.1 is not a function of Poisson ratio of the soil. Okay. So, yang ini adalah untuk concentrated load ataupun point load. Okay. So, any question? No? Ada soalan?
Maksud dia dia punya dekat point A, reaction bila point load dekat P tu kena kat tanah kan?
Tak dengar. Ulang balik, kuat sikit.
Untuk dia punya equation ni, kita nak cari reaction force apabila point load dekat P tu SZ dekat tanah kan?
Betul. When you apply load P, okay, and then how much stress has developed on the soil. Okay, tapi dalam case ni, kita bukan nak kira dekat surface tanah tu. Kita nak kira dalam tanah tu. So, berapa jarak tu? Okay, they put it as Z. Okay, as Z. Okay, maybe katakanlah Z adalah 3 meter. So, bila awak dah ada loading atas tu, okay, imagine you have, okay, katakan awak bawa kereta, awak parking dekat situ. Okay, so, kalau dekat surface tu, the loading on top is just the kereta. But now you also have, sekarang ni awak nak ukur the stress 3 meter below. So maksudnya kereta campur tanah 3 meter bawah tu. Faham? Okay? Azam? Alright. Okay, so going back to your notes. Okay. So just now was point load. Okay. Now what about if you have a circularly loaded area? Okay. Alright. So same guy, Busines. Okay. So they use the vertical stress below the center of a flexible circularly loaded area as shown in figure 8.2. Okay, so dalam figure 8.2, let the radius of the loaded area be B over 2. Okay, so R, okay, your radius of circular is taken as B over 2 because normally they would assume diameter as B, as the breadth. Okay, so B over 2 and let Q naught, okay, let Q naught, which is your imposed loading, okay, be the uniformly distributed load per unit area. Okay, so Q naught is applied all over. So you see this is Q naught, Q naught, Q naught, Q naught. So all Q naught. And to determine the stress increase at point A, okay, so first we want to find at point A. So berapa banyak loading stress increase dekat point A. Located at depth Z, okay, so panjang ni adalah Z, okay, katakanlah ini berapa, 10 meter, okay, so berapa loading ni awak letak secara circularly loaded area tapi dekat kedalaman 10 meter, okay, so below the center of the circular area, consider an elemental area of the circle. The load on this elemental area may be taken to be point load and expressed as Q naught R D theta dr. Okay, so awak kena buat pembezaan lah kat sini. Okay, but here we assume we assume it is as point load. Sebabnya katakan awak letak dekat sini, so dekat center tu jugalah awak nak cari. So you can assume it as a point load. So this is the equation. Okay, so now is different with just now. Okay, because this is circularly loaded area. Okay, so you have to do the pembezaan untuk area tu. If you look carefully, okay, dia lebih kurang je macam rumus yang tadi 3P kan. So now P tu dia dah expand kan. Dia dah pakai Q0 kali R kali D theta dr. Okay, and then you see it is pretty similar. Okay, 2 pi z squares 1 plus rz square 5/2, and it is also the same here. It's just that P tu dia dah berbeza sebab tadi tu point load, yang ini dia adalah circularly loaded area. Okay, so the total increase in stress A caused by the entire loaded area may be obtained by integrating equation 8.2. Okay, so sorry, bukan pembezaan. Pembezaan apa? Integrate pembezaan siapa tak ingat, pengamiran pembezaan. Okey, apa dia?
Pengamiran.
Okey, so pengamiran lah. Okey, so awak kena kamirkan. Okey, so dia punya limit adalah berapa, daripada 0 sampai 2 pi and then 0 sampai b/2. Okey, so this is the the non-dimensional equation. Okay, nanti kita akan tengok the dimensional equation. Okay, so kali dengan Q0 lah. Okay, this is still a slightly similar equation. Okay, increase in vertical stress under uniformly loaded flexible circular area. Okay, so ini adalah untuk cari dekat point A. Okay. Okay, similar integration could be performed to obtain the vertical stress increase at point A prime. Okay, so A prime ni, okay, katakan kedalaman yang sama, but you want to measure it differently. Okay, so this is R. Okay, so R is the distance for point A prime from the center of the circularly loaded area. Okay, so located a distance R from the center of the loaded area at a depth Z. Okay, Alvin and table 8.1 gives the variation of changes in sigma over Q0 with R over B/2 and Z over B/2 for R over B/2 in between 0 and 1. Note that variation of delta of changes of stress over Q0 with depth at R over B/2 equals to 0 can be obtained from equation 8.3. Okay, alright, so variation of changes in stress over Q0 for uniformly loaded flexible circular area. Okay, so apakah katakan kita nak tengok yang ini. Okay, kita belum habis lagi kira dia. Okay, but they have made some coefficients, some values for variations for us to follow. Okay, so katakan awak masuk ke R over B/2. Okay, so B/2 is actually your diameter. Okay, katakan diameter is 4. So B/2 is 2/2 lah. And R adalah sama dengan dia punya radius dekat mana awak nak check loading tu. Okay, dia bukan sampai hujung tau. Kalau tadi tu B/2 means B from point here to here is B. Okay, so in this case half of it, but R is not until the end, it's just until where your A prime is. Okay, alright, so if given the Z, the B/2, the R, the B/2, then you can get your variations or changes in stress over Q0. Okay, so ini adalah untuk circularly loaded area. Okay, so is still okay? Any question?
Okay, Doktor.
Okay, alright. The vertical stress increase. Okay, stress due to a line load. Okay, now we are talking about line load. Okay, so tadi itu point. Okay, tadi itu point, satu titik, and then that titik is giving you the loading. What if it's actually a line? Okay, so the whole line is giving you a loading. So figure 8.3 shows a vertical flexible line load of infinite length that has an intensity Q over unit length on the surface of a semi-infinite solid mass. The vertical stress increase, changes of stress inside the solid mass can be determined by using the principle of theory of elasticity. Okay, so so untuk line load, okay, so ini adalah xz prime. Okay, I can't really explain the logical explanation of this unless we derive it, which somehow I will fast forward. Okay, so I'm just gonna carry on. Okay, but this is for the equation for the line load. Okay, this equation can be rewritten as, so if you simplify or expand it, okay, so you can get this one. And finally, changes in stress over Q over Z. Okay, know that equation 8.5 is a non-dimensional form. Using this equation, we can calculate the variation of changes in stress over Q over Z with X over Z. Okay, alright. So yang tadi tu, okay, so kita cakap pasal line load lah. Okay, so imagine line load tu, okay, dia adalah satu line, okay, di atas, okay. So and then kita nak check dekat point A juga. So you understand point A is not directly underneath the point load, okay. So dia ada jarak dia, okay. So jarak dia from the line load is X and the depth is Z, okay. And then we can have a look at your changes in stress, okay. So in this case, we follow table 8.2, okay. So in changes of stress, yeah.
Apa beza dengan point load? Line load dengan point load ni apa beza dia?
Point load ni, okay. Point load ni adalah satu titik. Okay. Imagine jelah satu point tu, okay. And then line load ni means you have the loading comes in line. Nanti saya cari gambar lah. And then I show you. Okay. Is that okay?
Boleh.
Okay, kita carry on dulu. Sebab dah nak habis pukul 5 dah. Okay. Alright. Mana? Okay, so for this one, okay. So delta changes in stress over Q over Z with X over Z, okay. So all we have to know is the X over Z, okay. So untuk line load ni, okay, alright. So we have to know the distance, okay, X dan Z ni, okay. So dua tu je lah. So katakanlah X ni 5, okay, and maybe the Z is 20. So X over 5 over 20, it's berapa? 5 over 20, 0.4. Betul? 5 over 20, 0.4 lah kan?
Betul.
0.4, okay. So this is the one lah, okay. Alright, so changes in stress calculated by using equation 8.5 is the additional stress on the soil caused by the line load, okay. The value of changes in stress does not include the overburden pressure of the soil above point A. Okay, 8.5, equation 8.5, mana? Equation 8.5 is the caused by the line load. Okay, alright. Okay. Okay, alright. Nanti kita tengok contoh. Okay. Alright, so line load, okay. Last sekali saya nak masuk yang ini. Lepas tu we call it a day. Dan nanti next kita buat example. Okay ke? Ada 5 minutes lagi.
Okay, doktor.
Okay,
Okey,
alright.
doktor.
sudah terus rectangular. Perfect. Alright. Okay, so stress below a vertical strip load of finite width and infinite length. Okay, so maksudnya width tu awak tahu, okay, tapi dia punya panjang tu you don't know, it's infinite. Okay, it's a strip loading. Okay, ibarat macam awak buat strip footing lah. Okay, so lebar tu awak tahu tapi panjang tu tak ke mana-mana. It goes on and on. Okay, so the fundamental equation for the vertical stress increase at a point in soil mass as a result of line load section 8.4 can be used to determine the vertical stress at point caused by flexible straight load of width B. Okay, so dia cakap kat sini width B dah bagi, okay, tapi dia punya length tak tahu. Okay, let the load per unit area of the strip shown in figure 8.4 be equal to Q0. Okay, so load tu letak adalah sama dengan Q0. Okay, if we consider the elemental strip of width dr, the load per unit length of the strip is equal to Q0 dr. Okay, so Q0 tadi tu, okay, awak akan kamilkan dengan the changes of dia punya R. Okay, the somehow like the radius lah, but it's not radius lah. In this ni kita infinite length lah. Okay, so this elemental strip can be treated as a line load. Equation 8.4 gives the vertical stress increase delta changes in stress at point A inside the soil mass caused by the elemental strip load. Okay, so to calculate the vertical stress increase, we need to substitute Q0 dr for Q and X minus R. Okay, for X. Okay, so okay, I'm not going through the whole equation, but mana dia punya ni ah? Okay, so this is the main equation. Okay, so this is the main equation, but it's still in pengamiran lah. So you need to do the the pengamiran. Okay, so variation of changes in stress over Q0 with 2Z over B and 2X over B. Okay, so you use table 8.3 for 2Z over B. Okay, daripada 0 sampai sampai 0 sampai the table is because 0 sampai 1.0 and then 1.1 sampai 2.0. Okay, alright, so okay, so this is for the vertical and the horizontal stress below a vertical strip load of finite width and infinite length. Okay, alright. Okay, so this is the width. Okay, so this is fixed. Okay, then this is R, changes in dr, load per unit area, X minus R. Okay, so point A is where you want to find the changes in stress is. Okay, X is the distance from the point load lah, and the location of the load. Okay, alright, so okay, so kita tengok ni lah, a quick one. Okay, just a quick one for stress below horizontal strip. Tadi vertical strip. Okay, alright, so refer to figure 8.4. Okay, so they are using this figure. Okay, they are using this figure. B kat sini, R kat sini, X minus R at point A, load per unit area. Okay, alright, so since 1 is less than B over 2 equals to 2. Okay, B over 2 means dia punya breadth tadi, dan breadth tu, sorry, berapa banyak breadth dia? Breadth dia 4. Okay, so 4 bagi 2 dapat 2. Okay, so X 1 meter is smaller than 2 meter. Okay, so from the equation, okay, so the limit from minus B over 2 to plus B over 2, the total increase in vertical stress, delta stress at point A caused by the entire strip load or with P can be determined by integration limit of R B over 2 or plus B over 2. Okay, so This is the equation. Tangent with respect to you can be kept in mind. B over 2 are in radians. Okay, alright. P over 2. Okay, alright. So this equation, okay, the data, the changes in stress, okay, is referring, okay, to this one, okay, with respect to 8.7. So tadi tu yang ini the main equation. Okay, and then as you expand it, okay, you can get this one. Okay, so x must be more than b over 2. Okay, the equation A is valid as shown in figure 8.4, that is for point A. X is more than b.2. Okay, so x is more than b over 2. Okay, so in our case, okay, okay, x is 1, okay, is less than b over 2. Okay, so b over 2 is 4 over 2. Okay, so b over 2 is larger than 1. Okay, so minus 1. Kalau tak, tangent Q0. Okay, alright. Minus, okay, plus minus tangent. Okay, in radians. Okay. For x is less than b over 2, for this case should be replaced by 5 plus tangent. Okay, alright. Okay, I believe they actually used this one, okay, for the reason that x is smaller than b over 2. Okay, alright. So as you carry on, okay, tangent minus 1 z, okay, over x minus v over 2. Okay, alright, and for this case, okay, alright. It's quite lengthy lah juga for this one. Okay, I don't think I've done this one before in the class, but I think, yeah, I think we, okay, figure 8.4 given b equals to 4 and q0 equals to 100. For point A, z equals to 1. Okay, so z turun 1 and x equals to 1. Determine the vertical stress and use equation 8.7. Okay, so they mentioned to use 8.7. Okay, so we have to use this equation. Okay, alright, so it is given, okay, that we have to use this equation, although from minus b over 2 plus b over 2. Okay, so basically we just use this equation to find the changes in stress. Okay, so q0 kita dah ada 100, pi we know, tangent minus 1, z kita dah tahu 1, b kita dah tahu 4, x kita dah tahu 1. Okay, so if you look into the equation, okay, so they just fill it in. Okay, and this is after, this is the equation ni panjang kan. This is the equation. Okay, ni sampai sini. Okay, until forever. Okay, and we know the b, we know the z, we know the x. Okay, x is 1, z is 1, b is 4. Okay, so as you just fill in the equation, okay, and finally you can get minus 45. Okay, but please be reminded that it should be in radian. Okay, the equation is in radian. Okay, you see, are in radians. Okay, so you have to convert it into radians. Okay, so finally minus 0.8, 0.0902, it's data changes in stress over Q0. Okay, so this is 8902 Q0, check. Okay, for finally Q0 is 100, so you get 90.2 km per meter square. Okay, I'm so sorry, I've been rushing to complete before 5. So okay, so this is actually very simple. Okay, I'll let you go through by yourself. Okay, and I've actually assist you, okay, throughout this example. Okay, so like I mentioned, this is equation 8.7. Okay, you know z, you know b, you know q0, you know z, you know x. Okay, so this one can be settled. Okay, finally you get the degree. Okay, and then change it into radian. Okay, so this equation, okay, is changes in stress over Q naught. Okay, so we know Q naught. Okay, and then we just fill it in with the changes of stress 9.02 times 100. You get 90.2. Okay, so at point A, okay, so at point A here, okay, the stress increase here is 90.2 kilonewton per meter squared. Okay, is that okay? Hello.
Hello.
Okay. Are you okay?
Nak kena revise balik lah, slow.
Okay. Alright. So nanti you revise that example. Okay, and then we continue with the horizontal, and then we have rectangular and isobar. Saya tak ajar isobar. Okay, tapi ada satu tu, this is Newmark method. Okay, the Newmark method is very important. Okay, so I will teach you the Newmark method. Okay, and then that will be all for that chapter. And then we have to jump to your apa nama benda tu? Settlement sebelum awak masuk piling. Okay. Settlement. Okay. Alright, so tonight's quiz is at 9:30. Okay, so it will be on your UKM folio. Quiz is just 15 minutes for 3 questions MCQ. It will be very easy. It's 3 marks for you. You just have to answer it. Okay? Is that okay, everybody?
Doctor, is there any calculation question?
I'm not so sure. There might be very easy ones, or there might be none. Okay?
Okay, Doctor.
Alright. So I'll see you on 24th ada talk Okay, tolong saya minta kindly register, okay, with the I structure E Dah register belum?
Dah, Doktor.
Dah, Doktor.
Sudah.
Okay. Alright, very good. Okay, thank you so much. So I see you on the 24th for the iStrat E. And then Dr. Easy is 25th. Okay. Well, you're gonna have a very busy week before your holidays. And if I cannot complete this chapter, I might have to use actually you have 24, 25, 26, 3 days consecutive seminars, webinars. Enjoy. Okay, alright. So kalau dah tak ada apa-apa lagi, terima kasih banyak. Assalamualaikum dan selamat petang.
Waalaikumsalam.
Thank you, Doktor.
Alright.
Thank you, Doktor.
Thank you, Doktor.
Di sinilah universiti yang mengilhamkan masa depan. Masa depan generasi muda. Masa depan cara hidup kita. Masa depan negara ini. Dan masa depan bermula dengan mencipta pelbagai penerokaan